Alright, welcome to our first pre-calc lesson. Our first unit is going to cover matrices. So before we can start working with matrices, we first need to identify what a matrix is. So, a matrix is a rectangular array of numbers, usually enclosed using brackets or parentheses. Now, primarily in this class, we're going to use brackets. Okay. Each number is called an entry or an element of the matrix. Now, when we're describing matrices, we need to know some information about the rows and the columns. So, just real quick, a row in a matrix is a set of numbers aligned horizontally. A column is a set of numbers aligned vertically. So, looking at my matrix A there, we would say that it has 2 rows and 3 columns. Okay, so 2 rows, 3 columns. Now, once we know how many rows and columns we have, that gives us the dimension of the matrix. And once we have our dimension, we can start adding and subtracting and all that stuff. So, first things first, let's find the dimensions. So, dimensions are represented by the rows by the columns, so m by n. We say m rows by n columns, or just m by n. So, looking at problem 1 here, I see that I have 3 rows, so 3 and 1 column by 1. So that is a 3 by 1 matrix. Example 2, I have 2 rows and 3 columns. And the last one here, I have 3 rows and 3 columns, so 3 by 3. When the numbers are the same, we call that a square matrix. Now, once I have the dimension, I can start doing some operations on them. So first, let's look at adding or subtracting. Now, in order to add or subtract 2 matrices, they must be the same dimension. So always start there. Looking at number 4, let's find our dimensions. So that first matrix is a 2 by 2. Second matrix is 2 by 2. And since they're the same, I can add them. Now, when we add matrices, we're going to add the elements located in the same position from each matrix. So, looking at example 4, I'm going to take the first element of the first matrix, and I'm going to add it to the first element of the second matrix. So, 2 plus negative 3. Now, looking at the second elements, I have 4 and 2. So 4 plus 2. Third element, 1 and 4. So 1 plus 4. And the fourth element, so 0 plus 6. So my answer, 2 plus negative 3 is negative 1. 4 plus 2 is 6. 1 plus 4 is 5. 0 plus 6 is 6. So there's my answer matrix. Now, when we deal with subtraction, we want to basically change it into an addition problem. And the way I do that is I'm going to distribute that negative into that second matrix and change all the signs of the numbers inside. But first, let's start by finding our dimensions. So first matrix is a 3 by 2. Second matrix, 3 by 2. So they're both the same, meaning I can subtract. Now, let's change this into an addition problem. So I'm going to distribute that negative, meaning I'm going to change all the signs inside that second matrix. So negative, negative, positive, negative, positive, negative. Now I'm just going to add it the same way I did problem 4. But this time I'm going to shorthand it a little bit. So first element plus first element. So 4 plus negative 2 gives me 2. Second element plus second element. 6 plus negative 3 gives me 3. Third element plus third element. Negative 2 plus 4 leaves me with 2. fourth element, 2 plus negative 2. That gives me 0. 1 plus 3 gives me with 4. And the last elements. So I have 5 plus negative 1, which leaves me with 4. And there's my answer. Now, the next thing we're going to look at is scalar multiplication. So think about when we had a problem like 2 times x plus 4. What did we do with that 2? Well, we distribute it, right? Same principle here. If I have a number in front of the matrix, I'm going to distribute that number to everything inside of the matrix. So I'm going to distribute that 4 to everything inside. Now, you don't have to show this every time. I'm just showing it for this problem. So my answer, 4 times 7 is 28. 4 times negative 1. 4 times 4. 4 times 3 is 12. 4 times 0, 0. 4 times 8, 32. 4 times negative 9 is negative 36. 4 times 6 is 24. And 4 times negative 5 is negative 20. And there's my answer. Now, looking at number 7, we can combine those two concepts we just talked about. So if you look at number 7, I have that 3 out front of the first matrix, and then I have addition. So first, let's take care of that 3. So I'm going to distribute that to everything inside. So 3 times negative 1, 3 times 4 is 12, 3 times 5 is 15, 3 times 0 is 0. Now I'm just going to rewrite that second matrix. Okay. Now I'm going to add them. So remember, I'm going to add the elements that are located in the same position. So first element plus first element. Negative 3 plus negative 2 is negative 5. 12 plus 1 is 13. 15 plus 5 gives me 20. And 0 plus negative 3 gives me negative 3. Alright, the last thing we're going to talk about today, and it is the most complicated part of matrix operations, is multiplication. Now, when I'm multiplying two matrices together, again, we're always going to start by finding the dimensions. Now, if the first matrix columns match the second matrix rows, so when I put the two dimensions next to each other, if these two numbers are the same, that means that I can multiply, all right? Then, once I multiply, my answer matrix will be the two outside numbers, which gives me m by p. Okay? So, looking at A, so I have the dimensions of matrix A and the dimensions of matrix B, and it's asking, is the multiplication of those two matrices going to be defined or undefined? Meaning, can I multiply them or can I not multiply them? So, looking at matrix A's columns and matrix B's rows, those numbers are the same, which means, yes, it is defined, meaning I can multiply. And when I multiply, the dimensions that my answer is going to be, it's going to be a 2 by 3 matrix. So B, look at those two middle numbers, 7 and 7. They are the same, so I can multiply. And the dimensions of my answer matrix will be a 5 by 2 matrix. 2 and 2, those are the same. So again, I can multiply, and the answer will be a 10 by 13 matrix. Looking at D. So again, looking at matrix A's columns and matrix B's rows, those numbers are not the same. So no, I can't multiply, and it will not have an answer matrix. Okay? For problems like that, we say that it is undefined. Same thing with E. Those numbers don't match up, so we cannot multiply. Now, let's look at actually multiplying two matrices together. So when we multiply, we need to find something called the dot product of rows and columns. So dot product means we're going to multiply the matching members of the first matrix row and the second matrix columns, and then we add them together. So what that looks like, I feel like it's more helpful when we actually kind of write it out. So for this problem, I'm going to write out all the steps, okay? So I'm going to take the first row, and I'm going to multiply it by the first column. And I'm actually going to write that out. So the first element and the first element. So we would have negative 5 times negative 2. And we're going to add. I'm going to look at the second element and the second element. So negative 5 times 3. That'll give me my answer for that first entry of my answer matrix. Now, staying with that first row, I want to find the second entry of my answer matrix. So first row, second column. So again, first entry times first entry. So negative 5 times negative 3, always adding. Second entry times second entry, negative 5 times 5. Now, same thing for the bottom row. So bottom row, first column, first entry times first entry. So negative 1 times negative 2 plus second entry, 2 times 3. And lastly, bottom row, second column, first entry, first entry. So negative 1 times negative 3 plus second entry times second entry, 2 times 5. Now, I like to kind of do the multiplying right underneath before I add. So negative 5 times negative 2 is 10. Negative 5 times 3 is negative 15. Adding those together, I get negative 5. Negative 5 times negative 3 is positive 15. Negative 5 times 5 is negative 25. Adding those together, I get negative 10. Negative 1 times negative 2 is positive 2. 2 times 3 is 6, so that would leave me with 8. Negative 1 times negative 3 is positive 3. 2 times 5 is 10. Adding those would give me 13, and there is my answer. All right? Now, looking at number 10. Number 10 is very similar. Okay, it's just a little bit longer. So if you want to go ahead and pause the video and try this one on your own first, go ahead. I'm going to do this one a little bit more shorthand so you guys can see how to do this a little bit quicker. So, first row, first column. Now, when I say shorthand, I'm just going to do the multiplying part now and just leave it as a addition statement. So, 3 times negative 1 gives me negative 3 plus negative 1 times negative 4 gives me 4. Okay, so that makes it go a little bit quicker. First row, second column. So 3 times 6 gives me 18 plus negative 1 times 1 gives me negative 1. Second row, first column. So negative 3 times negative 1 is 3 plus 6 times negative 4 is negative 24. Second row, second column. Negative 3 times 6 is negative 18 plus 6 times 1 is 6. Last row, first column. So negative 2 times negative 1 is 2, plus 5 times negative 4 is negative 20. And the last part, running out of colors. Bottom row, second column. So negative 2 times 6, negative 12, plus 5 times 1 is 5. Now my last step is just doing that addition. So, negative 3 plus 4 is 1. 18 plus negative 1 is 17. 3 plus negative 24 is negative 21. Negative 18 plus 6 is negative 12. 2 plus negative 20 is negative 18. And negative 12 plus 5 is negative 7. And there is my answer. Alright, last problem here, number 11. Again, start with finding your dimensions here. So I have a 2 by 3, multiplying it by a 2 by 3. So I see that the columns aren't the same as the rows. So I will not be able to multiply this. So my answer here would just be undefined.